everyone. Thank you for joining us. We are Team 3. My name is Jamit, and my teammates are Rujal, Mansa, Shashank, and Pratik. And we are excited to present our Spring 2025 Supply Chain Engineering project. In this project, we will address a key vulnerability in semiconductor manufacturing, where the raw material supply instability. We propose a solution for Infineon Technologies by drawing inspiration from how the metal and mining industries handle supply chain disruptions. Let's go to the slide two. So before we get into the Infineon supply chain, let's upstream. We begin our research by analyzing the metal and mining industry, the source of critical materials like copper, nickel, and lithium, all of which are essential for EV batteries and semiconductors. This image has captured the transformation journey raw materials extracted by mining eventually power uh, the, uh, the micron chip using high-tech systems. This is the slide three, which is business challenging and market trends. The metal and mining industry is facing three major business challenges. Environmental regulations are getting tighter, forcing cleaner, traceable mining operations. Second is resource scarcity, especially for the lithium and nickel, is making it harder to meet growing global demands. And third is geopolitical instability. But there is an innovation happening. The key market trends includes like smart mining and with IoT and automations, and vertical integration where the mining firms manage everything from like extraction to export. The fourth slide is industry overview. So here the metal and mining industry is currently valued at over 2 trillion globally and is growing steadily. Um, this growth is driven largely by the demand of EV, clean energy systems, and all of which are required a heavy use of copper, lithium, and nickel. What's important is to realize that this semiconductor production depends on entirely on this upstream industry. And delay or a disruption can have a ripple effect downstream. Um, Now my friend Ruja will explain further.
Thank you, Jamit. So let's take a look at industry supply chain challenges. Now let's get into specifics. There are three key operational challenges in mining supply chain. First is remote site logistics. Mines are often located in geographical difficult regions like desert, mountains, or sometimes politically unstable zones. So the transportation cost gets high and sometimes it often gets delayed by the terrain and infrastructure issues. Second one is volatile demand forecasting. So market demand for metal can shift rapidly. A new EV policy or let's say a lithium price spike can often throw off the procurement planning for months. Third one is inventory visibility gap. Many companies still rely on delayed reporting or manual inventory updates. This results in excessive stocks and sometimes critical shortage at others. So these problems often limit the responsiveness and upstream and resilient, and it creates the problem for downstream companies like Infineon. So we asked, like, what if Infineon could adopt mining approaches like buffer in itself for its disruption? Next slide, please. Okay. So this is the BHP case study for smart port optimization. Let's take a look at what BHP did. So their problem was insufficient bulk loading at ports, which led to long delays and high cost fees. So the proposed solution was they introduced an AI-based port and vessel scheduling system, which used real-time data optimization where the ship was docked and how the cargo was loaded and how quickly the ship departed. So the results were quite dramatic. We can see like a 25% of reduction in loading time and over 50 million were annually saved on this. What does this tell us? Like AI plus visibility plus smart scheduling gives us huge efficiency gain, which we wanted to translate into logic and raw material handling at semiconductor fabrication. The next slide will be shown by Mansa.
In this slide, let's take a world example from Vale, a major supplier of nickel, a material essential to electric vehicle production. Vale faced supply challenges due to price volatility and supply risk in unstable regions. To manage this, they introduced AI-driven scheduling at export terminals, which significantly boosted logistics efficiency. The result is a 25% faster vessel turnaround and annual savings of over $50 million. This case underscores how smart logistics and proactive planning can greatly enhance operational performance and reduce costs. Key lessons for companies managing complex supply chains. In next slide, we will shift our focus to Infineon Technology, which is a global semiconductor leader and a central player in the EV and industrial electronics ecosystem. Known for its advanced chip technologies, Infineon powers many of the systems behind modern mobility, automation, and smart energy solutions. We will just go over the overview of Infineon in the next slide. It was originally a division of Siemens and became an independent company in 1999. It is headquartered in Germany and currently employs over 58,000 people worldwide. The company specializes in semiconductors that drive energy efficiency and secure connectivity across automotive, industrial, and consumer electronic sectors. And also, Infineon is advancing cutting edge technologies using materials like silicon and gallium. Its broad portfolio includes power semiconductors, microcontrollers, sensors, and connectivity chips, all enabling intelligent system solutions across global markets. Ultimately, Infineon's innovation supports not just technological advancement, but also more secure, efficient, and eco conscious systems worldwide. The next part will be explained by Shashank.
Thank you, Mansa. We have gone through all the problems which are faced in the supply chain industry, but now we will be focusing on all the issues at Infineon. A few of the major supply chain issues were no buffer inventory is maintained, a limited upstream visibility, volatile raw material prices. Since these materials are rare earth metals, the prices can be inflated and deflated at any point of the time. Over dependency on high risk regions. One of the examples can be taken as China. Emergency procurement costs is also very common in these procurement based industries. Next slide, please. The problem we will be solving uh, at Infineon is with buffer inventory. One of the major delays which have been caused in Infineon is due to no buffer inventory and which has led to frequent delay. Once we put in the place of buffer inventory at Infineon, it prevents stockouts, stabilizes the revenue flow, maximizes the sale opportunities, whereas new members are joining new suppliers and new OEMs with extra demand, mitigates the supply chain disruptions. It gives the organization a bit of breathing space once they have the buffer inventory, balances the inventory cost and service levels, and mainly addresses seasonal and demand variations. Next slide, please. In order to put this buffer institution in place, we have come up with a budget justification of $300,000 on initial inventory purchase. Storage and warehousing facilities will be approximately 150,000. The IoT and inventory tracking system will be around 100,000, and suppliers and legal compliance will be around 75,000. When we discussed these numbers with the Infineon team, they were really impressed with these numbers, and they kept the mitigation and the contingency cost at a lower version of 2.5%, which is around $25,000. Uh, and the total estimate will be around 650,000. Next slide. This slide will be explained by my teammate Pratik. Thank you.
Yeah, hello. Yeah, now talking about the project milestones, I structured this project over five clear phases to ensure the smooth execution. In the first month, we focus on aligning goals and identifying potential risks. And then the months, 2 and 3 are for onboarding the key suppliers and then finalizing the contracts to lock in the reliability. And then from months 4 to 6, we move into the procurement and payroll setup, laying the foundation for operations. And then basically, the IoT development happens between 7 to 8 months, 7 to 9 months, enabling no real-time tracking and smart visibility. And then finally, the last phase focuses on live monitoring, performance evaluation to assess scalability and the impact of the project at the global level. Now going on to the next slide, where I'll talk about the resources required. So executing this plan needs a mix of strategic expertise in technical infrastructure, sourcing and warehousing teams handle operations, while the IT analytics team enables smart decision making. And then basically the cybersecurity protects the digital systems. The legal advisors ensure contract compliance. And then sustainability auditors and regional warehouses, help keep the project both ethical and efficient. Together, these resources create a strong foundation for implementation. And then going on to the next slide, where I'll talk about the interview takeaway from Kaushik is that he gave us a practical lens into the value for buffer inventory. He stressed that it's more than just about just handling the stock. it's a strategic way of managing uncertainty and avoiding disruptions. He also shared how IoT and analytics drive faster, more accurate inventory decisions. And then importantly, the approach borrows from mining a sector, from handling volatile supply chains, making it adaptable and proven. And then his insights confirm that our proposal is both realistic and high impact. Thank you.